Right now, as you're watching this video, somewhere in our galaxy, a star is being born. And the process is way more violent and mind-blowing than anything you learned in school. We're talking about cosmic clouds collapsing under their own weight, temperatures reaching 15 million degrees, and explosions that can be seen across the entire universe. In the next 11 minutes, you're going to witness the complete journey of stellar birth, from the first gravitational twitch to the moment nuclear fusion ignites. And by the end, you'll understand why some stars live for billions of years while others explode in just a few million. Let's get into it. But first, we need to rewind to the beginning, to the darkest, coldest places in the galaxy. Stars don't just appear out of nowhere. They're born in gigantic structures called molecular clouds. These are massive regions of space filled with hydrogen gas and dust. And when I say massive, I mean it. A single molecular cloud can be hundreds of light years across and contain enough material to make 10,000 stars like our sun. These clouds are cold, really cold. We're talking about 10 to 20 degrees above absolute zero. That's negative 440 degrees Fahrenheit. At these temperatures, atoms move incredibly slowly. The gas is so spread out that if you were floating inside one, you wouldn't even know it. It's less dense than the best laboratory vacuum on Earth. For millions of years, these clouds just drift through space, doing absolutely nothing. Just cold gas and dust floating in the cosmic void. But then something happens. A supernova explodes nearby, or two galaxies collide, or a massive star passes through the cloud. This cosmic disturbance sends a shock wave rippling through the cloud. And that's when everything changes. The shock wave compresses parts of the cloud, pushing gas and dust together. Suddenly, certain regions become denser than their surroundings. And here's where gravity becomes the star of the show. These denser regions start pulling in more material from around them. The more mass they accumulate, the stronger their gravitational pull becomes. This creates a runaway process. More mass means more gravity. More gravity means more mass. It's an unstoppable cosmic snowball effect. As the cloud collapses inward, something incredible happens. The gas starts heating up, not from fire or combustion, but from gravitational compression. Think about pumping up a bicycle tire. The pump gets hot because you're compressing air. The same principle applies here, except on a scale that's literally astronomical. Over the next 100,000 years, the collapsing cloud fragment becomes what astronomers call a protostar. It's not quite a star yet, but it's getting there. The protostar continues pulling in material and getting hotter. Its core temperature climbs from thousands of degrees to millions of degrees. And then, when the core reaches about 10 million degrees Celsius, something magical happens. Nuclear fusion ignites. This is the moment a star is truly born. Hydrogen atoms in the core start fusing together to form helium. And this process releases an absolutely insane amount of energy. How much energy? Every second, a star like our sun converts 4 million tons of matter into pure energy. That's Einstein's famous equation, E equals mc squared, in action. This energy creates an outward pressure that perfectly balances the inward pull of gravity. The star reaches what's called hydrostatic equilibrium. Without this balance, stars couldn't exist. Too much gravity, and they'd collapse. Too much pressure, and they'd explode. But when the two forces are equal, you get stable fusion for billions of years. But here's the thing. The birth of a star isn't peaceful. It's one of the most violent events in the universe. As fusion begins, the newborn star doesn't just sit there quietly. It starts blasting out powerful stellar winds that can reach speeds of millions of miles per hour. These winds slam into the remaining gas and dust around the star, creating shock waves and pushing material away. Young stars also shoot out jets of material from their poles at nearly the speed of light. These jets can stretch for light years through space. If you could watch a stellar nursery and fast forward, you'd see it lit up by these jets, glowing with ultraviolet radiation and constantly churning with stellar winds. The most massive stars are especially destructive. Their radiation is so intense that it literally evaporates the surrounding gas cloud. This is why stellar nurseries are so beautiful in telescope images. The newborn stars illuminate and sculpt the gas around them into spectacular shapes. The famous pillars of creation in the Eagle Nebula, those are actually stellar nurseries being slowly destroyed by the very stars they created. Eventually, after a few million years, the young stars clear away most of the gas and dust. The nursery disperses, leaving behind a cluster of newborn stars. But not all of these stars are created equal. Some are massive blue giants. Others are tiny red dwarfs. Why? It all comes down to how much material the protostar managed to gather before fusion began. The more mass it accumulated, the bigger and hotter the star becomes. A star needs at least 8% the mass of our Sun to ignite fusion. Below that threshold, you get a brown dwarf, which is basically a failed star. On the other end of the spectrum, stars can't grow beyond about 150 times the Sun's mass. Above that, their radiation pressure is so strong it blows away any additional material. Here's the wild part. The bigger the star, the shorter it lives. Massive stars burn through their fuel in just a few million years. But small red dwarfs? They can live for trillions of years. In fact, no red dwarf has ever died yet because the universe isn't old enough. Our Sun is right in the middle. It's about 4.6 billion years old and has another 5 billion years to go before it exhausts its fuel. And the craziest part? This entire process is happening right now, all across the galaxy. As of 2026, astronomers estimate that about 7 new stars are born in the Milky Way every single year. That means in the time it took you to watch this video, somewhere out there, a cloud of gas began its journey to becoming a star. If this video blew your mind, smash that like button and subscribe to Your Space Wizard for more cosmic knowledge that'll change how you see the universe. Remember, every single atom in your body was forged inside a star billions of years ago. We're all made of stardust, born from the same violent cosmic processes we just explored. The universe is constantly creating new stars, new worlds, and new possibilities. And now you understand exactly how it happens. Stay curious, Space Wizard.